years or so, and then also take a look forward and where are the areas that you're most excited about where nanotechnology might play an impact in the future?
I think people often overestimate where we are in nanotechnology. I know there's conspiracy theories that we have these nanobots that are going to infect people and do stuff. And I tell people if that were real and I could do that, I would have the Nobel Prize in the bag, right? And the truth is we're just not there. We're not. You'll hear this term scalable nanomanufacturing, which is talking about how to make a whole bunch of something that we know how to make in the lab, but when we just try to make the beaker bigger, it doesn't work. And we need ways to be able to make kilograms of this, not micrograms. And that in itself is a whole set of challenges, but that's actually what chemical engineers do. Our main job is scaling things up. So that is a place where I personally am very comfortable and a lot of my colleagues work. The other piece, though, is integration. And I have all these nanoparticles, and sometimes they're made directly in a device through, say, molecular beam epitaxy, but other times they're made in solution, and then I need to place them in a specific location. And remembering that I can't really pick these things up because they're so small, that becomes quite a challenge. And so the field has looked at things like self-assembly and bottom-up nanomanufacturing. And this is an area where there hasn't been as much work done historically. And so there's a lot of room to research and to learn and grow.
For decades, Ray Kurzweil has been an unofficial spokesman for the transhumanist movement. And in 2008, he said that humans would become infused with nanorobots, which would vastly improve the human body, put in place. But the technology was patented and deployed to billions of people without their knowledge in 2020. We know this because several independent labs have confirmed the presence of this nanotechnology in the COVID vaccines. And Bill Gates recently admitted to this as well.
Making the mRNA is really easy and really cheap, and that's the magic of this thing. But there's no doubt in the next 5 years, we just need to mess around. There's a lot of lipid nanoparticles, and some are very self-assembling.
Self-assembly and self-replication seem to be the same technology when it comes to nanorobots. And this was considered to be the greatest danger involved with the use of this technology.
Self-replication causes disease. Nanorobots are inherently much stronger than biological systems being built of diamondoids. So if they self-replicate, that disease, quote unquote, could be even a tougher problem than biological disease. So first of all, what's the feasibility of self-replication in the nanotechnology world?
As a general principle, you do not want to put self-replicating nanorobots inside the human body. I suppose not everybody agrees with me on that, but that is the way I think that we can best guarantee safety. If the nanorobots are able to replicate inside the human body, that means they are using some component of the human body as food, and we don't want them to be doing that.
In his 1986 book, Engines of Creation, Kim Eric Drexler wrote about what he termed the gray goo scenario, a hypothetical catastrophic event caused by out-of-control, self-replicating nanotechnology, which consumes the biomass of the host. And this is exactly what independent researchers are finding. It explains the large, so-called blood clots being found in the dead. And it's spreading. Evidence shows that the vaxxed are shedding this to the unvaxxed. But the event is worldwide, and there is no agency set up to put out this fire. Our governments are not even discussing the problem, and the perpetrators are planning a second round of nanobot deployment with another fake pandemic. If we the people cannot unite and stand together now, then what exactly are we? Reporting for InfoWars, this is Greg Reese.